Hello everybody and welcome to my YouTube channel once again. In today's video I will show you how can you keep your data confidential by using one of the most relevant Rails 7 new features, Active Record Encryption. Active Record Encryption makes encryption transparent by encrypting data when persisting it and decrypting data upon retrieval. In other words, to you, it will feel as if the data wasn't encrypted at all when you are working with your application, but under the hood, Active Record will be persisting that data encrypted. On top of that, it also filters out the parameters that you mark it as encrypted from the logs, which is great when you are dealing with PII, and it also helps you to comply with GDPR and CCPA regulations. So before we start setting up Active Record Encryption, let me tell you that there are two encryption modes. One is the non-deterministic and the other one is the deterministic mode. And I think that is good that you first know the differences between both of them. So let's start by looking at those in detail. When using the non-deterministic approach, encrypting the same content with the same key twice will result in two different ciphertexts. The advantage of this approach is that it clearly makes harder for an attacker to make cryptanalysis of the ciphertexts. It also makes it impossible to query the database, which is an advantage from the security point of view, but it could be a disadvantage if we want to search that data. And that's basically what the deterministic mode does. With the deterministic mode, if you encrypt the same value with the same key twice, they will produce the same result. That means that if you persist something in the database, then you will be able to query that because Active Record will then be able to encrypt the data again with the same value and compare that with the value that's already persisted in the database. Both deterministic and non-deterministic approaches use the same encryption algorithm. The difference between them is the initialization vector. The non-deterministic approach uses a random initialization vector, whereas the deterministic approach generates the initialization vector from the key and the contents that are going to be persisted. But enough theory for now, let's set up Active Record Encryption in our Rails application and see how it works. So let's start by configuring Active Record Encryption, which by the way is super simple. The only thing you need to do is copy some keys into your credentials file. And on top of that, Active Record Encryption already has a command, which is Rails DB encryption init, which generates those commands for you. So the only thing you need to do is copy these commands here and enter them in your credentials file. In my case, I'm going to do it in the main credential file, in the application credentials file. I'm not going to add them in any specific environment credentials file, but you could do that too. If you wanted to have different encryption values in production or in your development environment, for example. So I have already copied these keys in this credentials file here. So let me tell you what these keys are used for. First of all, the primary key is used for non-deterministic encryption, And as you can imagine, deterministic key is used for encryption when you are using deterministic encryption. And the key derivation salt is used to derive the keys. So, some comments about this. If you are not using deterministic encryption at all, you could omit this deterministic key. Since we will be using this in this example, I will leave it as it is. And the other thing I wanted to comment is that you could have several keys for the non-deterministic encryption. That means that non-deterministic encryption supports key rotation, which by the way, deterministic encryption by the time I'm making this video can't support. So in order to support key rotation, you would instead of having a single key here, you would have a list. So, and that list would look like this. You will have here the first key, which is, for example, the one that you used to encrypt some values in the past, and then you would rotate the key, come here and run the command again, and it will give you a different key. So what will happen here is that the new values would be encrypted with the last key you are using, while Active Record Encryption would keep trying with all the other keys, I mean not all the other, with all the keys in the list to decrypt the values. So all the keys in the list will be used to decrypt the values because maybe you had encrypted that value in the past and it was encrypted with a previous key. So it will be trying each of those keys until one matches. As you can imagine, doing that is a little bit, let's say, not very optimal. So what you can do is go to your application, and in their application you could set this option here if you were going to use key rotation, which is basically telling Active Record Encryption that it should store a reference to the key that was used when encrypting the value, the original value, in the payload, so in the database, so that it doesn't have to try every key that you have set in the configuration. Instead of that, it will have the reference already and it will be much faster. But since we are not using that, again, we leave it as it is. So let me show you the example I have prepared for you in order to demonstrate the Active Record Encryption. We will have two models here. A secret agent model, which is going to be used to show the non-deterministic encryption, and the user model that will be used to show the deterministic encryption, since we will want to query users by email in the example. So let's start first with the non-deterministic encryption and the secret agent. The secret agent is going to represent a secret agent in the real world, and secret agents have, of course, a code name that can be known by everyone, which is going to be a string, and also they have a real name, which is also going to be a string, but we want to encrypt this one because we don't want the bad guys to know the real name of our agent. And on top of that, this is also going to be a rich text description field that doesn't need to be in this migration because rich text fields are persisted in a separated relation in database. So, as you can imagine, the encryption doesn't come for free, or that's at least what they tell us in the Active Record Encryption guides. That means that the payload generated by the encryption process needs some extra space in the database, which they say that it isn't a problem for text fields, so that's the reason why we are not going to change anything there. But in the case of strings, we need to change the default 225 bytes length that these strings have to 510. So we are going to add a limit of 510 to this migration here, and that should be it. I mean, there is, as you may already know, when you are adding a limit to a migration here, which is dealing with a string, you're actually not limiting the number of bytes, but the number of characters. And some characters may have more than 1 byte. But since we are going to store only very short names here, this is not going to be a problem. The only thing I want you to have in mind is that you need to take this extra space that the encryption payload is going to add into account. That's the only thing. So, as you can imagine, I have already run the migration. So, let's see what we need to add to our secret agent model in order to encrypt those fields. So, for string fields, what you need to add is basically encrypts, tell that it wants you to encrypt the real name. And that's basically it. And for rich text, it's as easy as adding the encrypted true option. And that's it. So let's go to the terminal and see how it looks like. So if we open the console, the Rails console, we can add a secret agent here. So let's create one and say that the code name is going to be solo, and the real name, the one that we don't want but the bad guys to know, is going to be Napoleon. So Napoleon solo. And then the description, which should also not fall into the wrong hands, is going to be that he is the number 1 of section 2 in uncle. So if we create that, if you take a look to the transaction, you already see that there is some encrypted values here. So as you can see, the code name is persisted in the same way as we have introduced it here, but the real name is persisted. And it has this strange string here. So, and also if you take a look to the description, as we said, which is persisted in this other relation here, it also has the same payload, I mean at least the same form. You see here that again this is a hash which is represented as a string here, and it has some keys like P, H, you see here also IV, AT, right? So what does that mean? If you take a look to this one here, for example, for the real name, you see that first of all this is a string. So the first thing about this that the Rails guides tell us that is that everything we want to encrypt should be serializable as a string. As in this case we are persisting a string, it's a no-brainer. So let's look at the values here, at the values of this hash in detail. We see that there are two main values. First one of them is P and the second one is H. So P actually represents the encrypted value of the real name that we have introduced here. So this P here, this value here, is the encrypted form of Napoleon. And then H represents the encryption headers, which are two of them. This one here is the initialization vector that we have used to encrypt this value. And the other one, AT, stands for auth token. And this is a value that is used in the decryption process in order to control, to check that the value here hasn't been modified. So, and with that said, as you can see, we are dealing here in the application, as we said before, in our code, we are dealing with non-encrypted values, so completely transparent to us. And if we retrieve that, if we were going to retrieve the first secret agent and we look at the real name, we see that we are getting Napoleon, although it has been persisted here in a encrypted form. So that's completely transparent to us. So now let's clear this and focus in the other example I have for you. So if you remember, we said that for security reasons we will be using only the deterministic approach when we need to query the data, which is the case of this user example here, in which we are going to query the users by email. So as you see, this is a string field, so the only thing we need to do in the users model is to, as before, as we said, to add an encrypts email here, but since we are going to use the deterministic approach, we need to add the option deterministic true. So what this makes is that when we go to the console and create one user, for example, we create a user for me, which is going to have the email alberto@example.com, and as you see, it's persisted here with the email in a persisted form. And if we create, for example, another user, so that you see that there are different users, the database. Okay, again, we persisted the user with different email. So if we want to fetch the user, say for example, the user is going to be user find by email and alberto@example.com, we can now fetch the user, which has this email here, because the deterministic function is generating the same value here as here, which is pretty important in order to be able to search the data in the database. The disadvantage of this, besides the security issues we mentioned before, is that it's only looking for equality here, because as this is persisted in an encrypted way, the encryption values here, this value and this value, need to match. So you can find by pattern, for example, if to say that the email starts with Alberto @ or something like that. You need to check for equality, but this is needed. I mean, adding the deterministic true option is needed if you want to at least be able to query by equality. Okay, now you have seen how to add Active Record Encryption to a new application with new data. But what happens if you want to use Active Record Encryption in an application that already has data and you want to encrypt a field that already has data on it? So, fortunately, Active Record Encryption has a configuration option to do that allows encrypted and non-encrypted values to coexist. Of course, the final goal should be to have all the data encrypted, but this configuration option can give you some room so that you start working with encryption. I mean, the new values will be encrypted when they are persisted into the database, but at the same time, Active Record Encryption will not raise an exception when it's dealing with unencrypted data, so that you can encrypt the data in the meanwhile. And now that we are talking about encryption, do you remember HashSecure password from my last video? So with HashSecure password there was also an encryption process. But first of all, let's say that they are completely different features thought for completely different problems. HashSecure password was only built with the idea in mind of encrypting passwords, and that means that it's not reversible. So once you have encrypted a password, it will not be possible to decrypt it again, which is great when dealing with passwords because you don't want anyone to be able to see the passwords again in their original form once you have encrypted them. So as you can imagine, there are many other configuration options you could add to Active Record Encryption, but if we talk about all of them, this video will be too long. I will leave you in the description down below a link to the Rails guides so that you can check them, and in case you have any question, you can leave me a comment down below so that we can talk about them. And also, if you want, I can make a dedicated video on one of those. And that was it for today. If you liked the video, please don't forget to smash the like button, and also please subscribe to my channel so that you don't miss any further updates. And without further ado, I hope to see you in my next video. Adios!